This conference will
Uh,
now be recorded.
One of the version is Python 2 and the other is Python 3. So there are basic differences between the two of them. So first I'll discuss about those, and then I'll switch on to Python 3, which is the latest version. So here I have an online console for Python 2. So one of the difference between Python 3 and Python 2 is the first and foremost is the print statement. Here it uses print statement, whereas in Python it uses print function. So while writing the code, only the basic difference would be the parenthesis, as you can see here. But it comes out to be a major difference while actually coding. And then the second difference is the use of a function named as xrange. So in Python 2, we had two functions, namely xrange and range. So as you can see here in the output, xrange does not give an output to us, while range function gives an output of 0 to 8, which is basically your starting 9 indices. But in Python 3, we only have the range function. So the Python 3 range function, I'll show you just right now. So as you can see,
Recording
it
में
also it,
अभी जरूरत नहीं है बार हेलो
yeah, I'll just mute all. I'll give you time for asking doubts, but just in case, if you still want to keep your points, you can just put it in the chat. Otherwise, there would be some communication issues. So as I was saying that in Python 3 as well, the range function just returns the range object of 0 to 9. So this major difference was actually chosen because if you see, the X range is actually similar to the range in Python 3. So we can just say that in from migration from Python 2 to Python 3, the range function of Python 2 was removed. The reason being it returns a memory of the size which we define in range. So for bigger numbers, so suppose this is just 9 which I gave, right? So if we gave a very big number like 1 million or something, then it would take up that space. While in X range of Python 2 or range in Python 3, they take the number dynamically, meaning that whenever we need the number, it will be allocated to it. So that is one of the difference. Thirdly, we have the referencing of variable. So suppose I is one variable which I might have been using for some of the computation, but in generally when we are going through iterations, we make use of letters such as I, K, Z, etc. So here we did the same, and we can see that the value of I changed here. But if you move on to Python 3, the value of I will remain the same. So that is one of the benefits, that even after computation, the referencing does not changes. And then we have another important difference, which is regarding strings. So here a normal string is byte data type in Python 2, whereas in Python 3 it is in Unicode. So why this major difference was taken out? Because if you have byte encoded data type as string, then you can only uh, keep up 256, maximum 256 characters. So you can only have the ASCII and the extended ASCII. So ASCII is 120 until 0 to 127, and extended ASCII is till 255. But there are many characters which we actually deal with, and that's why we needed Unicode. So here, as you can see, when I checked, is instance is a function which will check for the which will basically check whether the object that you have is of the type which I define afterwards. So here I can see that it's not a Unicode, it's an str. And if I want a Unicode, I had to prefix U here. But in Python, it's an str is by default a Unicode. And lastly, the divisions in Python are integer based. So both of the divisions, as you can see, generated the output 1. So they gave an output as integer. So I could not get any float computation by division here. But in Python, we have both normal divisions to get the output as integer and for float as well. So this is one of the benefits here. Now let's start with the basic data types in Python. So here the basic data types in Python which we deal with are integer, float, strings, and boolean. So these are the most basic data types. Apart from these, we have lists, tuples, and dictionaries as well, which I'll be discussing on later. But first, let's focus upon this. So I'll just take a pause and you can ask any doubts if you have right now. Or shall I carry on? Just let me know in the chat. Okay. Anupam, are you not able to see my screen? Because I guess everyone else is able to. I think so. Can everyone confirm on that? Okay. So only one question I got is that what are the pre-requirements for learning Python? So I would say that there is not much of a prerequisite which you require for learning Python. It's just that you must have at least a little background about coding in any language. It it might not be just C, Java, or Python. It can be your scripting languages, or it can be any other language as well. Python is different from R. Uh, Earlier, R was the preferred one for visualizations because R was taken as an open source alternative to MATLAB. So MATLAB was your licensed software used for visualizations and all plotting of graphs, but R came out as an open source library for that. But R has some of the restrictions due to which Python has taken the lead because Python, apart from doing data analytics, it has so many libraries which you can use. So you can create your own APIs, you can interact with databases, you can have a lot of functionalities, you can apply OOPs in it. Therefore, Python is the leading trend in market. There was one of the disadvantage in Python was the visualization was not as par as R, but recently I heard a news that the packages have improved in Python and are slowly to take on the visualizations, even the visualizations as compared to R as well. So that's why Python is preferred more. So let's head on to the basic data types first. So as I told you, in Python, the string is Unicode, and you can also have it as byte if you precede it with the B character. Similarly, in Python 2, you did it using U to get it as a Unicode. So in Python, we have a null type, which basically signifies when there is nothing. So if you have a variable whose memory has been fleshed out or which is not referring to anything, then that can be called as a none type variable. And it is different from your empty string because an empty string is still considered as a string in Python. So these two are very important to be noted when you will be dealing with database connections, because you'll have to keep a check when you are not getting any data and when you are getting an empty data. So other data types are float, integer. You also have complex numbers here. So as you can see, you can define complex numbers here. You have Boolean, and the last one I have printed just to show you that Python only has float. So if some of you have a background of C and Java, then you might be thinking that double data type is present or not. But in Python, only float data type is present. It's just that it has a precision of double as well. So for better understanding, you can just take it in a way that it's double in Python itself, but named as float only. So these are your basic data types, and I had already told you about different operations which we can do, like division. So this is your float division, and this is your integer division. Then basic operations of multiplication, addition are there. But there's one more additional feature is that you can have exponential as well. So you can give power uh, like this. So you can give 8 square like this here. And I have a question. No, none data type will not hold any values. So we don't initialize anything as none. That was just for the reference that whenever there is no value or the memory for a variable has been cleaned out, its type changes to as none type. So for this, I'll give you an example, because when I move on to the other data structures, other data types, this is something which I'll come back to. So after this, we have our list, tuples, strings, and the dictionaries as well. One thing I would like to introduce here, that Python supports indentation. So normally we have braces in your coding languages, right? But here we don't have any braces. Instead, we have what is called as indentation. So indentation defines how the code block is written. So for example, if I write any function, you can see that it indents. So it indents to 4 spaces, and then whatever I write would be the part of the function I have defined. And if I want to go outside the function, I'll have to go outside the indentation. So this is how the blocks are defined in Python. So now let's head on to list. So a simple list is defined in your square brackets, and then you can print it as well. So this is how a simple list is. List is your mutable data type, and by that I mean that you can change any data of it, and it is also heterogeneous. So you can have a list like this, So you can have a list of different data types as well. So this is one of the advantages of list, and for others who have a little coding background, they would know that in other languages we have something called as arrays. So this is, you can take it as a better version of an array. So now to know the length of a list, we have a len function which will give out the length of the list. We can also add to list. Suppose I have another list. So now if I print the resultant, you can see that I have both the list appended here. Also, there is another method to add elements to a list. Suppose this is my list and I want to append some data to it. Suppose I want to append this. So you can see I've added another element to it. And for attaching another list to it, there is a function called as extend. By that I can attach a list to it. We can also have a list object as a element of another list. So by that I mean that we can have a different list. Suppose this. So here you can see that we have a list as an element of another list. So this is something as a list in list. Now for iterating, we make use of indices. So here, although we call it as position 1, but in terms of iterating, it is taken as index 0. Okay, I have a question here that what is the difference between append and extend? So as I already showed you that for appending, whatever element you define would be added as a element of the list. So whatever data type, whatever value you define here will be added as the element of the list. But in extend, what it does is it identifies the element and attaches it as a list to the list. So by that I mean that in extend, if I do the same using the value high, you'll see the difference that the variable got broken up into a list and then it was added to the list. So here it was added as a single element, but here is what it was broken up into a list and then that list was added. So extend is basically used when I want to add up elements of two lists together. So basically I have two lists which is 1 2 3 and 1 2 3. So if I want all the elements to come out, then I make use of extend. But if I want only one element to be added, then I use the append. So as shown here in D, when I tried to append D here, D was a list. So it added the complete list as one element. But if I wanted all the elements of those lists to be added in as elements of these list of the list L, then I would have used extend. So this is one of the difference between append and extend. Now moving on to the accessing of your data. So as I told you, position 1 here means as uh, index number 0. So your L0 gave you the first element, which is your 1. Now here indicing, here the data is heterogeneous. So you must know the indices prior to it. But in case of a list where you have homogeneous data, you can access it using a single index and you will not get an error. Also, there is negative uh, indexing possible here. So suppose I used L minus 1, so that would give me the last element of the list. So it gave me -1. And yeah, so coming back to this heterogeneous list, suppose you wanted to access the last element. So you have something like this. Yeah. So here you have something like this, list as the last element. So it printed out the complete list to me. Now, as I know that it is a list, I can do further indexing of it as well. So if I want to access the element hello here, I'll just give the index value as 2. So this will be 0, 1, and 2, and it would print out hello to me. So when you have heterogeneous data, you need to have an understanding of the indices. But when you have homogeneous data, you just have a single index value to iterate through all the elements. Now there is another concept called as slicing, with which you can actually iterate through your values. So suppose I do this. So this actually means that I want the elements of the list L starting from your 1th index till 3 minus 1 index, which will be second index. So the result of this would be 2 comma 3. First, I'll just print the list. So this was my list. I wanted elements from the first index till second index. So here, just keep in mind, this is not the position, but actually the indices. So this is my first index, and I want the value still 3 minus 1. I can take the value as something like 6 for better understanding. Or maybe I'll take 4. Yeah. So the first index is included, but the last one is not. So it takes values from the indices value 1 till 3. So 1, 2, and 3 were included. And you can give another value which is called a step. So as you can see, I've added another element here at the end. So what this do is it will give you, it is called as a step counter. So here earlier, as you saw, that I was accessing elements till the third index, but the step counter by default here was 1, so it was going on one by one. But I want the step counter to be more or less according to my need. I can specify that here. So by specifying 2, it went 2 steps ahead instead of 1 step ahead, and gave me the output as 2 comma 4. So in slicing, these are the values which we can make use of while processing our data. Now we can define our list in certain ways, like we can make use of this. So here it created a list of size 4 for me with default value 0 as well. So someone had asked me regarding none as well. So this is how you can give none. You can have a list consisting of none as well, but it's just for demo purpose. It's not that you will be needing a list of none. So, but the usage of none I'll show you better when we'll be dealing with dictionaries. So this is some basic ways of creating and playing around with your list. You can also remove elements from your list by using a function called as pop. So pop actually returns the value which has been removed from the list. So if I print the list now, you can see that one element has been removed. So I'll just make use of a better list. Yeah. So here, as you can see, I had a list 1, 2, 4, 5, 6, and the last element got removed. So pop just basically returns the last element which is removed. You can also specify which element you want to remove. So suppose I specify 1. So it removed the element which was present at the first index. Now, apart from pop, you also have another function called as remove. So what remove does is you specify whatever value you want to remove. Suppose you don't want to give an index, you want to remove the element, but you know the value which you want to remove. So you can give that as well. So suppose I give the value as 4. So now you can see that the value 4 was removed. So these are two of the ways for removal of data from your list. Now let's head on to another data type, which is called as tuple. So tuple is basically your immutable object, which is defined by curly braces. Now, what do I mean by immutable is that uh, the value of a tuple, once you have defined it, cannot be changed. So if I print up here, I'll see 1, 2, 3, 4. Yeah, tuple also supports heterogeneous data for your information, but modifications are not allowed in a tuple. So that is what is meant by immutability. But if you on this, I'll show you how. So suppose here you have the list consisting of elements 1, 5, 6, right? So here if I write 0 as 100 and then I print L. So you can see the first element got replaced by the value 100. But if I do the same here, I'll get an error which says that tuple object does not support item assignment. So that is what I meant by immutability. So whenever you there are therefore many of your modification functions which we discussed about in list are not actually supported in tuple. But one thing is that if you try to make changes to a tuple, suppose you have another tuple 7, 8, 9, right? So now I have two tuples. This is just your normal concatenation, which we had discussed in list as well. It's supported in tuple as well. So here, whenever we make a change to a tuple, a new object or a new tuple object is created, and that's why we cannot make changes to a particular element in a tuple due to its immutable nature. But yes, if we try make changes to a tuple, it will certainly take up your memory because it will keep on creating a new object or keep on taking new memory whenever you try to modify it. So yeah, and tuple supports your slicing as I have already shown it to you. So it supports slicing because slicing is just a read operation. It does not make any changes to the tuple object, and it supports the length function as well. And there are other functions as well which are like to know the maximum or the minimum element. These are supported both in list and tuple, so I can have it in the list as well. And yeah, so this is what is mainly used in tuple. Now, I think a question might arise from all of you that why do we actually use tuple when we have a easier way of doing it using list? Because list is so free to use, right? But the thing is that in tuple, your data remains in a sequence and it is immutable. So since the data is not going to change once you initialize it, that means that you can iterate through it very easily, and not only easily, it will be actually faster as compared to tuple, as compared to list. Sorry. So this is one of the reasons why tuple is used. So for example, in cases when you have uh, a, a very big list of numbers or strings and you want to sort them out, or you want to do some operations regarding reading of that data, then in that cases tuple would be a better option in contrast to your normal list. So that is all about your tuples. Similarly, we can do some playing around with your normal strings as well. So I'll define two strings, and similarly to tuple, strings are also immutable. So once you make any changes to any string, it gets a new memory assigned to it, and that's why this is one of the similarities regarding properties of tuple and your strings. So this is a normal concatenation, similar to what we had seen in a list and a tuple, and we can do the same regarding slicing as well. So that is not an issue. It's only that we cannot make changes to it. And in string, the thing is that if we try to make any changes, for example, if I even want to have uppercase letters of the string, then this hello world is actually not saved in str3. It is actually sent out as a new memory. So as you can see, I have printed str3 even after running the function upper, but the value in str3 is still the same. So I will always need a new variable to store that for me. So this is what I actually meant by immutable nature. And similarly, you have many functions in strings, which I think you can have a look around, which is you can check whether a string is a digit. Sorry. You can check whether it is alphanumeric or it is an alphabet. So my string has all alphabets. That's why it returned true to me. I can also check for alphanumeric. Sorry. Yeah. So here in alphanumeric also it returned true to me because it satisfies the condition of alnumer. Because even if a numeric value is not present, but alphabetic values are present. And then you have your lower, upper is lower, and various other functions which you can use for going through your strings. Yeah, another important function might be the count function, which you can use. So this can give you the count of the letter L in your string. So if you have some counting problems or use cases which you want to work on, then that is one thing you can make use of. And lastly, you also have the max, which you can use, which just returns the maximum value present in that string. So yeah, you can ask all your doubts if you have any till now. So Arjit has one doubt, that how we can modify any string. Yeah, so as I told you that you can make modifications to a string. So as I have shown you here that str3.upper changed it to uppercases. It's only that it will return a new string to it. So I can also make it str3 and then I'll have the new value in the str3. But the thing is that the old value will be dereferenced, and if it is not being used by any variable, like for example str3 was using the old hello world, but now no variable is pointing to it, then that value will be removed, which is something called as garbage collection. So it is used for cleaning up memory so that we never have a memory problem. So in string you can make use of other functionalities as well. I'll just show you two. Yeah. So here I made use of replace function to replace element of the string. The only thing again is that I need a variable to hold that new value. So as you can see that a new value was returned, and that's how I can make changes to any string. Okay, there is another question from Shashi of how to remove leading and trailing blank spaces from words. So yeah, that's a very good question, because uh, in strings we normally have problems like we have strings like these, right? So when we print them, we get some leading and trailing uh, spaces present, and if I have another string which is like this, then comparing both of them would be difficult for me, because I have a function called as compare as well, or I can do a normal comparison using double equal to as well. So we can make use of double equal to as well for normal comparison of equality. So it gave me a false, right? Because obviously these leading and trailing spaces have caused those problems. So to remove those, we have a function called as strip. So what it does is it will return you the string with removing all the trailing and leading spaces in it, and after that you can make the comparison here. So what I can do is I can do a strip, and as you can see I got the equality here. So this is one of the important functions. Also another function is your split function. So suppose I have my s2 string, right? So I can split this function. I can split this string on the basis of the parameter which I gave. So I gave here a space as the parameter. So it returned a list to me, which uh, which consists of elements uh, taken up after splitting the string on the basis of the parameter I gave. So space was present between s and t, so it did a split there, and then the elements which is received it returned it in a form of list to me. So I can have a bigger string to make you understand that. Yeah. So this is how the split function works. It wherever it found a space, it just split the whole string on that, and then took out all the elements and created a list out of it. Now I can also specify different parameters to split. Suppose I want to split on the first space encountered. So then I can have only the first element which I want. Maybe I have some requirement like that. So I can specify that number on the basis of which I want the elements to be split. So this is one more advantage of using. And so we have another function, another question: how can we remove the internal space of a string? Okay, so if you want to remove the internal spaces, then there is a function which is called as join. So suppose I have this as a list now, or let's have it as complete list. So suppose these were all space separated, but we should not have had those spaces in the first place. So how to solve that problem? So I did a split on space. I got my list, and then what I did is I will be joining all the elements of those lists. So I'll use the join function on the list L, and here I can have my list without the internal spaces. So this join function here, the empty string just means that join all the elements with nothing between them. I can give a hash value as well, and I can have hash separated string present here. So that is depending upon whatever value I want, on the basis of which I want to have my string generated. So this is how I can remove the internal spacing of the strings. So I think these I have covered most of the functions of string. And I think there is one more thing which might come in handy. As I told you that in Python 2, ASCII characters were used as the string was byte. So here we have Unicode. But if we want to make use of the ASCII notations, then we have something called as CHR. So we have to give the ASCII value present to it. So we give a value, suppose 65. So I can show it to you here. Yeah. So here in ASCII value 65, we have the value as capital A, and in 97 we have the small a, and then we have similarly other values as well. So for just the purpose of example, I'm using an easy value. So we can get the values based upon ASCII values using the CHR value. This might not be used for many of the use cases because ASCII is not much supported now because of the limited range of it. But in case you want backward compatibility, you can make use of this. Now we have another function which is called as ID. It just returns the ID of the element because each variable will have an ID and a memory allocated to it. So ID function just gives you whatever ID it is using. Sorry, st2. Yeah. So it just returns whatever ID you are using. So this comes in handy when you are making changes to a value. So suppose I have a list which is 1, 2, 3, 4. I have a tuple which is 2. So if I use ID and if I use ID on tuple and then I make changes to my list and do an ID of my list. You can see the ID of the list does not change because I already told you that a list is a mutable object. So the ID is not going to change. The ID will only change when a new memory is allocated to it. So a new memory can only be allocated when you change the object itself. So now the ID has changed for the list. Similarly for tuple, I cannot do indice value assignment. That's why the ID change I cannot show you. And if I assign a new tuple to it, you already know that the memory will change to it. So that is one of the difference. And this function can be useful for checking out the change in memory for a particular variable. So with this, we are finally now back to our last data type, which is your dictionary. So there are actually two data types, dictionary and a set, but I'll first explain a lot about dictionary and then I'll move on to set. So your dictionary is mainly your key value pair data type. So you'll have a key and you'll have a value assigned to it. And when I print it, I will get all the values present. So, and if I want to access the value of a particular key, because I can only access the value when I know the key of it. So I can access it using the key and I'll get the corresponding value to it. This data type comes in handy, especially when you're dealing with hashing or you are dealing with API creation in which you have to work with JSON data. So this is just your JSON format in Python. And now there is one important thing which I would like to mention is that now suppose I have a float key value which has 45 as the value. So now what do you think would be printed when I access dict17? So let's see, the value came out to be 45. So this 45 did not come out because the float value was preferred. It was just taken on basis of what value was encountered first. So here we need to pay attention that whenever we are giving key values, we do not make use of float and integer. Mainly we make use of strings as keys because they make a very uh, better, they define very better for us. And this confusion of a string and of a float and an integer is taken out. So this is one of the benefits of uh, dictionary. We can also make use of functions to get values. Suppose I do this. So we can make use of this function to get the value which is present with this key. And I would recommend everyone to make use of get function instead of just using indices, because get function has one benefit over it, which is that even if you don't have a key corresponding to your value, it will still work. It would not give you any error. So as you can see, I did not get any error. And if I print the value, I get as none. So earlier I had talked about none, right? So this is the scenario in which I can actually check whether the value for a particular key is present or not. So I can basically check whether the value which is present is for that key value is present or not. So I got as true, so I'll definitely know that any value is not assigned to this key. So it can come in handy when I have a shortage of a list of keys, or I want to check whether the values for certain keys are present or not, or whether after updation made to the dictionary what are all the keys which do not have any values assigned to them. So this is one of the benefit of using the get function. Now similarly, if I make use of the indices, then I'll get an error which is called as the key error. I can make use of the same key. See, so I got a key error here, and uh, handling of error is very important while coding, and that's why we can avoid getting any unnecessary errors while coding by making use of the get function instead of your direct indicing. But yes, indices are helpful while assigning values. So you can have a value assigned and then you can check whether that value has a value assigned to it or not. So this was one of the benefit. How to find unique values. Dinesh, can you give some specific question because I actually could not understand what your question is. And Arjit has asked that x equals to 10 and y equals to 10, then ID will be same, but while passing equivalent. Arjit, I did not understand your question as well. How to remove duplicate values from data? Okay. Yeah, Dinesh, for your question, so yeah, that will be the next part which I will be discussing, which is called as set. But just to complete dictionary, I would like to let you know about different functions which are present here. Suppose we have one update function as well, which is used to update the value. So this will update the value of your dictionary and then you can get the value. Similarly, you can also know what are keys present in your dictionary and it will print out all the keys to you. You can also know what all items are present. So items are in key value format. So this is your key and this is your value. So similarly, you get a list of tuples here, as you can see. And you can also, if you want, then get only values present in the dictionary. So you will get a list of values present using this function. So these are the basics dictionary functions which you can use. And yeah, coming to your question, Dinesh, we have another object which is called as a set, which is defined by braces, and it keeps only unique values inside. So even if I define another 3, I won't get that 3 repeated here. So the use of it is definitely the question which you asked me. So suppose I have a list which has redundant data and on printing the list I get this. So what I can do is I can just make a set out of it. I can typecast it to set. I would get my set and I can even typecast it back to list. So by this way I got only the unique values out of my list. So set is basically used as the question which you asked me for removing duplicate values from your list or any iterable which can be tuple as well. In case of tuple is only that a new object would be assigned, and you can also have unique values of if you make use of dictionary.values and you want to see what are the unique values present in your dictionary, you can certainly do that because it returns a list. The functions returns a list to you. So this is all from my side. If you have any doubts, we can take those up. Okay, Minakshi has a question. In case of dictionary, if I assign different value for same key, it will overwrite. Yeah, definitely it will override, because suppose you have one key named as 6 and you give it a value 0. So now if I print it, see, 6 has the value 0, but I can change that value and assign anything which I want, and the value for it will be changed to 199, anything. So that is one benefit of using the dictionary, because you can have a single key, and it's not that it's not immutable. So once you define a value for a key, you can keep on changing it as well according to your need. That's why we make use of the update function. If we are passing similar big numbers in two variables, then it will give different ID. Okay, so you're saying that if we give some, yeah, this is what you're saying, right? Sorry. So yeah, here we are getting different ID values for numbers, and I don't think so that having smaller values. Okay, yeah. So we are having same IDs for small numbers, but different IDs for long numbers. So I'm not sure about the answer to this, but it is something related to how big numbers are uh, referenced in the memory in Python. So even if you assign the same number to it, in the memory it is assigned differently, and that's why the ID of it changed. So this is one of the reasons which I think is making the change in the ID, even though I provide the same number to it. So as you can see, this can also occur, I think, in the cases of huge decimal numbers as well. That depends upon how Python is actually saving them in the memory. And apart from this, any questions anyone has? Okay, if this was just a, I mean, basic introduction of Python and all the data types present here. And yeah, Ajit, I'll try to know the reason if this is not the one reason present behind that. And yeah, so if there are no questions, then I'll end the session. Thank you all for joining. I hope you got to learn a lot from this. Thank you.